Hi, it's Phil Kerner, the Tool and Die Guy, and you know it's 8:15 p.m. and I've still got the work clothes on, so been a busy day. So I'm very happy to introduce a new series tonight, Mold Making 101. Now, for those guys who've followed me for any amount of time, uh, last 15 years or so I've been in machining, which has been a lot of fun, but my background is injection mold making, and I've still got all the parts and drawers full of drawings to teach a class on mold making. So I'm going to release one of my first videos I recorded a few years ago tonight, and I'm interested to see who is interested in a mold making video. A lot of you guys I know are home machinists and hobbyists, but I've always said that to me, mold making is the Cadillac of the trade. And it was a lot different back then, back in the 80s and 90s when I did it, because we were still using a lot of manual machines, but the basics never change. A cavity, a core, you got to get the parts out with an ejector stroke, and you've got to get the plastic in with some sort of gate. So we're going to go through that, and tonight I'm going to introduce Mold Making 101, Part 1. Very curious to see the response to this. Hope you enjoy it.
All right, so let's get started. Welcome to Mold Making 101. I hope I've got some guys out there, gals out there that are students, people that have no idea what it takes to produce plastic parts. This is about 40 years in the making, and it's been a big deal for me to figure out how to produce this. But let's just start off with how plastic parts get started, the birth of a part, let's call it that. There are so many consumer products out there, and almost everything you see has some sort of a plastic component to it. And I've picked out just a variety of stuff. I've got a box of parts that over the years I have built the molds for. And let's just go through them for a second. So here we start with this a simple plastic box that would come in maybe a cabinet, and you put screws and bolts in it. Doesn't get much simpler than that. And then we've got some palm leaves for a toy set, believe it or not. But those are plastic, and they needed to have a mold built. This was a dollhouse, and for Little Tikes Toys. And it's obviously a very small dollhouse, but again, typical of a plastic part. This was for some sort of a jungle set for Little Tikes, and a bird's nest, plastic bird's nest, and it's got a pin on the back that's just snapped into the toy. For those of you who are parents and had to put toys together on Christmas Eve, maybe you saw this before. This is actually a hub for a toy car. This is a wheel hub, and a rubber wheel would go on the outside of this, and a lot of detail there with ribbing and gussets and things like that. Simple drinkware, promotional products, you put your name on the side, happy birthday Phil, order these by the dozen or the hundreds, and maybe even a simple, you can't call it a frisbee because that's trademarked, but they call them in the industry flyers, promotional flyers, because they fly, okay? So everything starts with a concept. Somebody somewhere says, I need plastic boxes to put in the cabinets I'm selling. So the first thing I need to teach you guys is that it starts off always with a concept. Somebody needs a plastic part, and in many cases it might be from an inventor who has no idea what it takes to produce a plastic mold, or I'm sorry, an injection mold that will produce this plastic part. So that's where we're going to get started, is talking about the elements of designing a part. And I'm not going to spend a lot of time on that, but just a little bit so you guys understand when a tool maker gets a set of drawings, they know there should be the basic elements of design. So let's pull out the drawing pad and do a few sketches of what a mold would look like for this part. And let's do a few sketches of what the designer should know as he's sketching out this part for his boss or whatever, and says, hey boss, we need these plastic containers. And let's say this is a company that builds metal cabinets and they have no idea of what it takes to build plastic parts, but they know they need these red containers. So let's start there. So for our first lesson, I'm going to start off with teaching the elements of product design for this simple plastic box. Now, when anybody would normally look at this, unless you have a very critical eye or have done this like I have for years, it just looks like a square box. But if you look very closely, and if I can get this in the camera correctly, these walls on the side of this box are not square to the bottom. There is a slight taper, and we in the industry call that draft. So let's talk about draft. You can't get plastic parts off of a mold unless there's draft on it. Yes, you can do it with a lot of side actions and crazy stuff. If you have to do it, it adds a lot of expense to it, and it can be done. An example would be a milk crate mold. You've all seen the milk crates. I think they sell them now in stores for storage, and those are straight. And there's a way they do that, and I'll explain that in a little another lesson. But your average plastic part has draft on it. So let's talk a little bit about material and draft. Every different material, and I don't know what this is. This was molded before they used to put the material codes on it for the recycling centers, so you knew which bin to put it in. But now they have a code on them somewhere inside that the customer really can't see, but if they go to recycle it, they know what material it is. But there's so many different types of material, and rule of thumb is the more brittle the material is, the harder it's going to be to get off of the press as it cures. So as a designer, you're looking at this and you pick out a material, and they wanted something nice and stiff and hard, which also makes it very brittle, but they've got to put some draft on it. So let's talk a little bit about draft for this particular part. So for this particular lesson, I'm going to use what I never would use for an engineering drawing. I'm going to use a charcoal pencil, which I hope will show up much better on the video. So as a designer, you've got this box, and it's 3 by 3 by 2 inches deep, and the normal thing to do would be to sketch it up and turn it into an engineering drawing. But what we're going to do is to enlarge this is show this. And I'm going to exaggerate it. And this is going to be a little bit of a section view, as if we cut this part right in half. You need a slight draft angle. Now, what happens is, as this molded part cures on the mold, it starts to stick to the sidewalls. And we're not talking about a lot, but it's enough that there's a problem here. If these walls are straight, when the part pushes out, it's going to put scratches on the side, which is really important because no customer wants to buy a part with big scuff marks on the side. The second thing it is because it's sucked onto the core of the back half of the mold, it's stuck. And there's going to be ejector pins here to push this part off. And it'll make it a lot easier for them if there's draft on the part. So as a mold maker, you get really used to seeing different angles, nothing straight except, and we'll talk about this later, but parting lines. So this has got a flat parting line, that's good. But the cavity and the core are all going to have draft on them. So that's why you see mold makers have so many ways to measure angles, ball dimensions, to double check where the cavity walls are at, where the core wall is at, because the wall thickness is very important on these parts. There's a minimum and maximum, and the thinner it gets, the harder it is for the mold to fill. The thicker it gets, the longer it takes for the mold to set. So you've got a trade-off here. Plastic injection molding for the molder is all about how fast can I mold these parts, because the faster he can mold them, the more money he can make. And the thicker you make the walls, the more material you use, and it all adds up. So what we're looking for is the perfect marriage of the correct wall stock, and most of the stuff I did over the years for Little Tykes Toys was usually about 80 thousandths. That was their magic number. 70 to 80 thousandths was their wall stock. And I'll get some mics out one of these lessons and I'll verify that for you, but that was very typical for them. So the trade-off on draft is that nobody, again, wants to get a part, though, that looks like a pyramid. So you're always trying to make the draft angles as minimal as possible, but still get the part off of the mold. So, again, as a mold maker, you get used to working with some really weird draft angles. So what should just be a square, what we would think would be a square core and a square cavity, could be 1 degree, it could be a quarter of a degree, it could be a half degree, it could be 3 degrees, depending on the material. And you know, tool makers and designers really rely on people to make sure, like certain materials need a lot of draft because they shrink so hard. Softer materials need less draft. But what ends up happening is if you don't have enough draft, again, on the mold, you've got a real cycle problem. I've seen molds without enough draft. When these ejector pins go to push the part off of the core, the pins go right through the mold. They shove right through because it's stuck so hard. So there's a lot of things that go into that also. The polishing is very important on these molds. But so your first lesson today, very basic lesson, is that every plastic part, for the most part, has some sort of a draft angle on both the core that cores out the inside and a matching angle on the outside. So if this is 1 degree on the inside, this is 1 degree on the outside, because we don't want uneven wall thickness, because that creates a problem too with the mold filling correctly. So it's a science, it's an art. A good designer, after years of experience, knows, you know, and now with the technology of the day, they can do mold flow analysis right on the computers. But the basics of mold design is, number one, what type of material you're using. Number two, how much draft is going to be required to let that material release from the mold without scratching the sidewalls. And the final thing I'll tell you is about those weird angles. This is a simple part, it's only a couple inches thick. So the draft of, this is 1 degree, 1 degree in an inch is, I believe, around 15 thousandths. So you're going to have about 30 thousandths over 2 inches. So the part to the consumer looks fairly straight, doesn't look like a pyramid. Now, if you put 5 degrees on that, you know, all of a sudden you end up with a part that looks like this. Well, that's not so pretty. So, and imagine if this part's 12 inches high. Now you've got a part, you've got to put minimal draft on, because if you only put even a quarter degree draft on a big long part like that, you're still going to get an angle, which may not be aesthetically pleasing to the consumer, but it's got to come off the mold. If you put 1 degree on that, now you've got a real cube, and if you put 5 degrees on that, you've got a part that looks like a pyramid. So there's always a trade-off with the draft angles, the height of the part, and again, we'll get into it, but you can make straight walls on parts, and it's a big deal to do that. It's very expensive, but if you insist on it, you can. So what I want to end with on this first video, you guys might want to consider purchasing this book. And I've had this with me since 1980, Mold Making and Die-Cast Dies for Metalworking Trainees. And we're going to go through a lot of this. It's still an excellent resource, and I don't get a commission for this, so everybody relax. But it's got some really good details on different presses and how different molds are assembled and what the processes are. And this is obviously, this is a compression mold. I can tell better what you're looking at. And once you learn mold making, there's injection molding, there's compression molds, there's transfer molds, and they all have a little different art to them. Most shops tend to specialize in their own area, but I've built die-cast dies, I've built injection molds, I've built unscrewing molds, built a lot of different molds. And so this would be a good resource for you. I've seen them online. I don't think they're expensive, and you might want to purchase that. So that's Mold Making 101, Part 1.
So I hope you found that informative, and I've got 8 or 9 more to go, and there'll be more after that if there's interest. But for fun tonight, I thought I'd just let you know if you like a lot of the stuff I post, the pictures and photos, you're just seeing the video lessons now. Just go to Instagram and go to the Tool and Die Guy, and there's the link right there. And I post something almost every day there. So a lot of fun photos there. And I'm a pretty good photographer. You're going to like what you see. So just check it out. Follow me on Instagram. You can keep up with me during the day. And by night, I'll keep getting the videos done. So I'm Phil Kerner, the Tool and Die Guy. And I'll be very interested to see the response to this first video. We'll see you on the next one, hopefully.